Welcome to this presentation of HP Verity microservice architecture. HP Verity follows a microservice model. And what this means is that all of the various components of the applications are broken down into a set of smaller, independently managed, independently scalable services. In order to achieve this, Verity utilizes a certain set of technologies, such as Docker for the packaging of those various service images, as well as the runtime, and Marathon and Mesos for the orchestration and the deployment of the services. So Marathon assists with the orchestration of the deployment of the various services. Marathon defines the deployment tasks, as well as the reservation of all of the various resources required for the services to run, how much CPU or how much memory, how much I/O is required for a service to run. Additionally, Marathon provides health check, which are built in so that when a service is deployed, they can be probed throughout their life cycle in order to make sure that they're still operational. Mesos provides resources for Marathon to deploy the various tasks. So Mesos presents resources as a cluster, or in our case, multiple clusters. So for Verity, the data processing service, for example, in this case, is used for all of the data processing related type of services. Gateway services are on a separate Mesos cluster in order to do things like deploying a user interface or any kind of front-end facing services. So because that cluster requires access to an outside network, it would be actually a separate layer and a separate cluster than the one used for data processing, which is actually only a backend service. The additional exciting advantage of using Mesos is that it completely abstracts the infrastructure away from those services. So a microservice can be deployed without actually have any hard dependency on the infrastructure behind it. It could be running on a cloud such as AWS or Azure, or on bare metal, or on a set of VMs. It completely abstracted away from that layer. Now, another interesting element here is the fact that Verity comes with a set of rich data processing capabilities. Classifications, text extraction, language detection, OCR, speech to text recognition, and those compute processes are actually quite demanding in terms of compute capacity. So it is extremely important for Verity to be able to allocate the compute capacity where it is the most needed. And I will illustrate that by starting some data sending job, sending data into a Verity account hosted in AWS. So all of those services that process those various documents are all tied together loosely through a set of queues. So when data comes in, a workflow service defines what needs to be done with that specific object. Does it need to be text extracted? Does it need to be passed through OCR? So this operates such more or less as a router. Now, in this particular case, data is sent for text extraction, and when text is extracted from, let's say, a Word document, an email, or any kind of object, the language is being detected. So what's interesting in our current scenario here is that the data is coming in at about 13 messages per second. The data coming out of this service, there's only one of those text extraction services, is going at a lower rate. We're about 9 per second, so about just 2/3. So as a consequence, what's happening here is that a backlog is starting to be generated. We obviously are not keeping up with the incoming rate. Now, with Verity's Marathon infrastructure and a autoscaler mechanism built in, this kind of condition can be identified, and some action can be automated in order to respond to this demand. So all of the services were okay and keeping up besides this text extraction service. The autoscaler realized that we were falling behind and deployed for 3 more text extraction services to respond to the throughput requirement. Those 3 services have been deployed. They are still in a deploying state because they are pending the health checks. And once the health check will be confirmed, they will be marked as fully deployed. But they've started to do some work. And we can see now that the queue has been completely drained and that we are at a steady state pretty much. There's as many documents coming in as many documents coming out of this data processing service. Now, what's interesting here, though, is that because we removed that bottleneck, as I was explaining, the next thing that happens to a document when you extracted text out of it is that you need to detect its language. Language detection service is another microservice and has now moved to becoming a bottleneck itself because there's more data coming in as the bottleneck have been removed from the text extraction. So as a consequence, a backlog is starting to create with that service. And the autoscaler integrated with Marathon has identified that this was a resource bottleneck and has requested additional language detection. As a consequence, the language detection rate dramatically increased and the backlog of messages just went back to 0. I am now going to shut down the data send process, and we should start to see the queues being drained. And the various services scaling back down. And this concludes my presentation. Thank you.